Okay, let's try number 16. Find the least surface area of a cylinder that can contain two liters, which is same as 2,000 cubic centimeters of fluid. And drawing a picture always helps your understanding. So let's draw a picture of a cylinder. What are we trying to do? We're trying to put fluid into this cylinder, right? So it's probably some kind of a metal can. And we're trying, this must be some guy in a company making cans and trying to see how he can use the least amount of metal to contain the most amount of fluid. That's what we're trying to help out. Okay. All right. So. I guess a can comes with a radius and a height. And what's the volume of the can?
2 liters.
First you have this area, right? Pi r squared. And then you multiply it by h. Pi r h. So when you have a cylinder object or a column, some people call this a prism, where all the cross sections have the same shape. In that case, you just have to find the area of the bottom and multiply by its height. So since the area of the circle is pi r squared, multiplying by the height gives you this volume. Okay. And since surface area is also mentioned, we need to know the surface area. Yes?
2 pi r squared?
No, the 2 pi, pi r squared is the area of the bottom, and then you multiply by h, it gives you the volume. Yeah. All right. Now, in order to know the surface area, you have to think about what constitutes the surface of this cylinder. And to figure that out, imagine yourself cutting through this side, and cutting this circle out, and opening up the side. Now, what shape would you get if you opened the side up?
Rectangle.
You're going to get a rectangle, right? The rectangle that you get will have the height. What will be the height?
H.
It'll be the same as h, right? What will be this length?
Circumference.
It will be the same as the circumference of this circle because this wraps around that circle, right? Now, what's the circumference of a circle?
2 pi r.
2 pi r. That's 2 pi r, and that's h, and therefore the area of this thing is 2 pi r h. But that's not all. You also have to have the area of the top plus the area of the bottom, so you get the surface area formula is what?
Pi r squared plus 2 pi r h.
Right. So you have pi r squared for the top, pi r squared for the bottom, 2 pi r h for the side. Okay. If you simplify this, since these are like terms, you can write it as 2 pi r squared, and since 2 pi is a common thing, we can factor the 2 pi, we can factor the pi out. Actually, we can factor the 2 pi out, and we will end up with r squared plus rh. All right. Now, which one's the target function, objective function? The surface or the volume?
The volume. Surface.
The surface is what we are trying to minimize, right? Least surface. You have to read the question and figure out what it is. The volume is actually what's given. Volume is given as 2,000. See, we'll try to think of R and H, all of them as in centimeters, and therefore it's good to use 2,000 because that's also in centimeters. So we will say 2,000 is the volume, so therefore this is equal to pi r squared h. So we get these two relations. Okay. All right. What's the constraint? The volume. That's the equation. What's the next step?
Solve one variable.
Which one?
H.
We take this and solve for h, right? So we take this, divide by pi r squared to the other side, and we get h equals to 2,000 over pi r squared. Then what do?
Plug it back in.
Put it back into your s, so that now s is a function of r only. So now you have s equals to 2 pi r squared plus r times 2,000 over pi r squared. R and one of the r's cancel. Okay, and then you then you just differentiate. Okay, so what's the derivative? 2r, and then 1 over r differentiates to negative 1 over r squared. Using that, I get minus 2,000 over pi r squared. And then you set this equal to 0. Which means this has to be equal to 0, right? So you have 2r minus 2,000 over pi r squared equal to 0. And you have a fraction, so what should we do? Multiply by the denominator, which is pi r squared. So I'm going to multiply by pi r squared, and that gives you 2 pi r cubed minus 2,000 equal to 0. And then you move this to the other side. 2 pi r cubed is 2,000. Divide by 2 pi, so you get r cubed equals to 2,000 over 2 pi. Okay, which we can simplify by canceling the 2, so it's 1,000 over pi. And then taking the cube root, you get cube root of 1,000 over pi. What's cube root of 1,000? 10. So you get r equals to 10 over cube root of pi. And you can't do anything more than anything to the cube root of pi, unfortunately. Okay, and then you can figure out what h is by plugging that number back into this formula. So let's try to figure out what h is. H is 2,000 over pi times 10 over cube root of pi. And to simplify this, you should first rewrite pi as cube root of pi cubed, right? Cube root of pi cubed is pi, right? And that way I can calculate these two, because that's pi cubed divided by pi, so it's pi squared. Also 2,000 divided by 10 is 200, so it's 200 over cube root of pi to the 4th, pi squared. That's what we get. And then we plug in this into our s, we plug in r into s, and then we have to find what s is. So s is 2 pi times this square, which is 100 over cube root of pi squared, plus 10 over cube root of pi times, this squared again, so it's squared. So, no, it's not squared, sorry.
Dr.
Yeah.
Did you square the r when you plugged it into the denominator? Or
Pi r squared.
You're right. I forgot to square. Okay, so that's right. So that will give me just pi itself, and then 10 squared is 100, so it will be 20. Okay, thank you. You saved me from making a very big error. Okay, so that's what we have. And therefore, when we plug in h, 20 over cube root of pi, and then that's 2 pi. This is pi times pi, that's pi squared. So these two have the same common denominator. So that means I can combine them. 10 times 20 is 200. 200 plus 100 is 300. And since this is cube root of pi cubed, divided by cube root of pi squared, it just gives you cube root of pi. And then 2 times 300 gives you 600. So that's your final answer, 600 times cube root of pi. Again, to really find out what's the approximate value of this, you probably want to plug this into a calculator and find the approximate value.
Yeah, hit the button.
Oh.